Alrighty, so today we're going to be looking at finding vertical asymptotes or holes or any identifying features in a polynomial or a rational function, okay? So you just finished watching your lesson, so it should be pretty straightforward, the general rules, but let's just jump right into some questions, right? So let's say I have something like x squared minus 9, and we are dividing it by x squared minus 5x, x plus 6. Does that work? 1 second. Yes, that works. Okay. So let's say this is our function. Step one, as we saw in our book, was to factor everything. Okay. So I'm going to look at my numerator and identify it as a difference of squares. So I know x squared minus 9 goes to x plus 3 times x minus 3. All right. And then I'm also going to factor my denominator. So x squared minus 5x plus 6. I'm looking for two numbers that multiply to positive 6 by add to negative 5. Right? So I can see that that is going to be x minus 3 times x minus 2. Okay? Good practice is to just quickly FOIL these back out in your head to make sure they do simplify to these and you're following all your factoring rules correctly. But anyway, continuing on. We now have this function, and what can we see? Well, they both have x minus 3. So we can simply cancel them out. And then what we're left with is a function that's x plus 3 and x minus 2. But once we cancel it out, there's a certain issue with our function. Well, x cannot be equal to 3, because if it's equal to 3, look at what happens to our function. Let's throw this in, and let's just look at the denominator, right? So 3 minus 3 and 3 minus 2. 3 minus 3 ends up simplifying to 0. So we have 0 times 1, and then we're dividing by 0, right? So that's an error. So in a scenario like this where you cancel out your denominator and you have to put a restriction, that's a hole. Okay? Very important concept, especially in this lesson, right? Let's look at a little bit more of a complex lesson, a complex question. So let's look at one that's like this, maybe. 2x to the power 3 minus 6x squared. And let's divide that by x to the 3 minus 3x squared minus 4x plus 12. So again, we have to follow the exact same rules, but this time the factoring is a little bit more difficult, right? Because we now need to factor top and bottom. So let's start with the top. It's only two terms, so let's look for a common factor between both of these, right? And right off the rip, I can see 2x squared goes into both of them. Okay, so I'm gonna factor it out, and I'm gonna put in x minus 3. Okay, and we can double check. 2x squared times x is 2x to the power 3, and 2x squared times negative 3 is negative 6x squared. Good, our top is factored. And now we have to check this part, right? So what I'm going to do, typically we have to check factors of d over a. So all the factors of 12 over 1. So factors of 12 are 4 and 3, 6 and 2, 12 and 1, right? So instead of going through and doing all of these, I'm going to go in and try my x minus 3. So let's see what happens when I plug in 3 for this function. So I'm just going to look at my denominator here. So we have 3 cubed minus 3 times 3 squared minus 4 times 3 plus 12. Okay, 3 cubed is going to be 27, and then minus 3 times 9 is going to be 27 again, right? 3 squared is 9, 9 times 3, 27, minus 4 times 3, so minus 12, plus 12. Okay, so right off the rip, you see these cancel, so it's equal to 0, right? But we're not done just yet, because what do we have to divide it by, right? We know x minus 3 is a factor of this bottom now. So let's go into some synthetic division now. So x to 3 minus 3x squared minus 4x plus 12. You can also use polynomial long division at this point, whatever you prefer, right? And we just found out that f of 3 is a factor. 3 gives us a 0. So we're going to take all our coefficients. 1, negative 3, negative 4, 12. You don't have to put the plus there. Synthetic division, bring the 1 down. 1 times 3 is positive 3, right? Negative 3 plus 3 is 0. 0 times -3 is -4, right? -4 plus 0. -4 times 3 is -12, and our remainder is 0. What does this mean? Well, this is the coefficient of x squared, this is the coefficient of x, and this is the constant. So we essentially have x squared minus 4 as our product, right? We multiply these two to get the bottom. We can simplify this even further because it's a difference of squares and go x plus 2, x minus 2 times x minus 3. Cool. So we just solved this to be our denominator in factored form. So we can now bring this back up. Put it in over here. Okay. Everything in our denominator is not allowed to be equal to 0 because we can't divide by 0. So here's the point where we're going to state our restrictions. Let's move it over here, have a little bit more space. So our restrictions, well, x is not able to be 3, x cannot be -2, and it cannot be 2. Okay. And now once we have our restrictions in our denominator, we can go ahead and cancel these out, right? And what we're left with is this function. 2x squared divided by x plus 2 times x minus 2, right? And yeah, that is our fully simplified version. And it tells us, well, we have a hole at 3. And then we have vertical asymptotes at -2 and 2, right? So that will help us immensely when we're drawing this graph. And we're going to use the rest of the rules of polynomial functions to kind of visualize this, right? And we'll go on to that a little more in the next lesson. But yeah, hope this was helpful. Thank you.